multi-digit whole numbers using a standard algorithm. So this is the typical way that we multiply. So my first example here is 1,367 times 8. So as we know, we line those up. 1,367 times 8. We want to solve this vertically. Now, when we solve this, we're going to distribute the 8 to every single number at the top, and using our typical regrouping rules. So if I have 8 times 7, we get 56. We always carry that 10. And then we have 48 plus 5, which is 53. We put a 3, carry the 5. 24 plus 5 is 29. We put a 9, we carry the 2. And 8 times 1 plus 2 is 10. So we have our answer using our standard algorithm. Okay. Last year they used the area model, which we had talked about in class will eventually lead to this. Okay, so that's our first example with a one-digit number. So we have a one-digit number. Now my next example is going to be using a two-digit number. Okay, so with this next example, again, I'm going to line them up vertically. 15,468 times 24. Now this one is a two-digit number we're multiplying by, so I should have two partial products that we'll be adding together. But the same thing we did with the first one, I'm going to distribute the 4 between all 5 of these numbers. So I'm going to quickly do that. So we have 32, then we have 27, 18, 21, and 6. So we have our first partial product. Then when we go to the tens place, we always have to add a 0 representing that place value of the 10. So we have that place value holder here before we start our next number. Now, I like to go ahead and cross out the numbers I use so we accidentally don't use them again. And I'm going to distribute the 2 between all of these numbers. So we have 16, carry the 1, 13, carry the 1. We have 9, so I don't need to carry anything. Then we have 10, where I carry the 1, and 2 plus 1 is 3. Now I have my two partial products, meaning I have part of my answer that I'm going to need to add together and make sure our addition is accurate. And you can see I tried to line them up perfectly so we don't get messed up in our addition. So we have 2 plus 0, we have 13, we carry the 1, we have 12, we carry the 1, we have 11, we carry the 1, we have 7, and we have 3. So we have our final answer using our algorithm of 371,232. And for my third example, we have our three-digit number. So I'm going to go ahead and line these up. So we have 1,264 times 784. And once again, now I have 3 digits. So the same thing we did up here, instead of 2 partial products, I should now have 3 partial products. So I'm going to quickly go ahead and do my multiplication. We're starting with the 4, and I have to distribute it to all 4 of those numbers. So I have 20, carry the 2, 18, carry the 1, 9, and 4. Now, since I'm now finished with the 4, I'm moving to the tens place, and I have to start my tens place with a 0. Now I distribute the 8 between all 4 numbers. We have 40, carry the 4, 32 plus 4 is 36, I carry my 3, 16 plus 3 is 19, I carry my 1, and 8 times 1 plus 1 is 9. So I have my second partial product, so I can go ahead and making sure I don't use those again. Now for my third partial product, I'm now in the hundreds place, so I have to write these 2 zeros to represent my place values for 100. And then I distribute the 7 between all 4 of these numbers. So we first off with 35, I carry the 3. 28 plus 3 is 31, I carry the 3. 14 plus 3 is 17, carry the 1. And then we have 7 plus 1 is going to be 8. So with my third partial product, I am now done with my multiplying. Now I have to add my 3 partial products together to get my full product for this particular problem. So I have 0, I have 8. If you add all these together, you get 20. I carry my 2. Looks like we have 16, carry a 1, 17, carry a 1, and 9. So I finished off this algorithm with 976,080. So we have our standard algorithm we've been working on, and it's going to be the basis for a lot of things we do this year. So I hope these examples help you.